Right.
So another approach that I'm going to tell you about is um expanding outwards. The way that it works is this, is that you pick a center. It could be whatever, like here it's B, right? The beginning, you just start at the beginning, and
Hmm.
then you start moving outwards, meaning you shift one pointer to the right and shift one pointer to the left. Now, notice here that if you're on B, you can't shift left to the well, you can't shift one of the pointers past B, right? Because then you're going out of bounds. So you're gonna have to figure that part out. But ultimately, what you want to do is like make a determination that you can't shift anymore. So the smallest palindrome is there is going to be a B. So now you shift the center to A, right?
Hmm.
You're on A and you look at the two pointers and you expand them out, right? So now they're
Right.
at
So you
B.
can you can you can just expand left or right from a
Exactly.
midpoint. Yeah, I
Exactly.
understand that.
Perfect.
That makes
So
sense.
can you try to think of something like, hey, how can I code this? And then there's a caveat to this one too that I want you to be aware of, right?
Hmm.
That works for all of the odd type of substrings, right?
Right.
So
Yeah. Yeah. It only works for the odd stuff.
it works for the odd stuff. So check out how they gave you an example there with S equals CBBD. That's an even example. So you're going to have to account for how would you account for a substring that's just BB, you know?
Right.
It should be pretty simple because it's just an odd and even kind of
Hmm.
mathematical problem based on how you traverse your indexes. But you can start coding some solution that you think, and then we can move.
Sure. Um, I'm thinking for the brute force, I could do a sliding window and start from there. Um, do like a double nested loop and then maybe um return like a string and that's been like appended to quite a bit, if that makes
Okay.
sense. So I mean, um, let's just get I mean, will the string ever be empty?
Could be.
Or maybe okay. Is that what we want? I mean, what do you want us to return in case it's empty? Like you want us to return the string or you want us to return like
Yeah.
nothing?
Um, well, it says there that it has to return a string. So
Sure. That's fine. And then now from here, um, I'll do my, so from here, we're going to be looking at the length. So this is the first loop, looking at one character. We need another loop to look at the next characters. So let's see from here. Now, what my issue here is that we need to keep track of obviously um like you said the if it is an even amount we need to account for the characters being similar so that when it's flipped it's going to be the same. And then for the odd amount, I guess all that matters is I guess in the case of BAB or ABA, it just matters on the two endpoints being the same.
okay.
And I assume the same check has to apply for bigger odd palindromes. So if I am to think about this correctly, I'll go ahead and um actually right here. I think I'll go ahead and given my limits, I want to set this up in a way to where I mean just give me a second to think. Um to where I can use these two for loops to basically do all the work for me, and I'll just set my substring equal to the range that they're in. So thing is, I want length s. So for I in range of length s, and then for j in range of length s, from here, um, I'll go ahead and do, oh, let me do it right here. Let me do, and then right there. Okay, I think I'm ready to start coding. So now that I have everything defined here, I'm gonna go ahead and, well, first off, I need to create um, a substring to put my thing to. So that's what I'll be doing. Um, Now I'll just call this, I guess, substring. Then we'll set that equal to an empty string. Now from here, what I want to happen is now that we're looking at each other character, I need to um I need to see if um substring at point I is equal to substring at point or the character at point B, and then from there we need to check if those values are correct. So I think from here I'll do this actually instead. Um, I'll go ahead and use maybe hmm, just give me a sec to think about what I'll need. I mean, if we're doing that way. Okay. So I think actually um well I have a question is I know this is like a Python only thing. Is slicing allowed?
Yeah. For slicing the sub string? Yeah,
Yeah.
absolutely. It's just the array syntax, right? So you just use the brackets and then use the colon to slice
Okay. Okay, that's
side.
good. Just want to make sure. I know some questions don't allow that.
Oh, really? Have
But
you come across something like that? Oh,
I've came across where like it was frowned on, but yeah.
okay.
Okay, let me just start doing this. So actually, I do want to change my for loop. So I want this for loop to start at our length, and I want it to go backwards. So how I'm gonna do that is I'll just make the last value -1, and it will end here. So and then I also need a sorry. No, I need this to go back 1. I need the -1 here for it to go backwards, and then I'll go ahead and place a 0 here to be the endpoint. Now we're gonna start the end of the string, and then we're gonna go back. So from here, I also want that as well if I'm going backwards. So I'll do this using the length. Should, put me at the end of the list, but I will make sure that I'm not stepping over I. So I'll go ahead and do that. Um, Now from here, uh, I could start to do the whole operation with creating the substring. I'll set that equal to s, and since we already have bounds which are given to us by I and j, I'll set a slice to j and then j plus I. And then since we already have a substring being created every j loop or every I loop as well, we will always generate a new substring to subs or new substring to substring, so we can check if substring is equal to the substring at the end. And if it is, which means that it is a substring, we can return this substring. And that should be the answer. then we can, I mean, just walk through the code. Obviously, we have the base check, which is to check if it's empty. And then right here, this is where a majority of the operation happens. We start at the end and we go back. So we go to zero, that's our endpoint, and we go back by -1. And then the next loop, we do the same thing, except we're making sure to stay clear of I, because we don't want these two to overlap or be the same value. And from there, we're gonna set our substring because this is all we need. All of our work should be inside this J loop because we are supposed to create a new substring every time we loop through this J.
Hmm.
So if the beginning is equal to the end, as is the pattern in substrings, we can return that substring. So I'll go ahead and write the test out right here. So and then okay, and then we can do CVVD, and that should be it. Unless you have some other things you want to do.
So let's okay. So let's walk through your solution. All right.
Right.
So can you walk me through? So I understand that with I, you want to start at the end of the array, right? And then you want to go inwards, right? So with J, I saw here that you also start J with the length of the array minus I, wherever the ith position plus one is. So
Hmm.
can you explain that, the reasoning
So,
behind
so you're talking about the loops, right? You want to understand what the loops are doing?
The J loop? Yeah.
So the J loop is going to be our starting position. So
Mm-hmm.
basically, we're able to create our substring given our ending position, which is going to be I, and then our starting position, which is going to be J.
Mm-hmm.
So we do that to then set our substring equal to S, which is sliced, to J being the starting position, and then J plus I being the next position.
Mm-hmm. Mm-hmm. Yep. Right. So how does that account for the odd and even scenarios? Is it?
Uh, I mean, in the case of, I know you said that, when it isn't even, you would want obviously um the value to be different. So how this works is that when it starts out
Mhm.
um as a, I guess, smaller uh like a smaller substring, obviously, because we start out at the end and we slowly go back and make sure that we're always going to be behind our, sorry, some noise. So when we go back with the outer for loop, it controls our um, length that we're going to be checking. And since we have the starting position with J, we basically extract a substring and check if it's a palindrome using our if conditional. And we return it instantly. Um, and I guess how that works is that since we can check it for the odd and the even cases, like you said. The substring, we're setting this equal to the reverse of the substring. If that makes
Mhm.
sense. So if
Mhm.
substring is equal to substring, which is reversed, then it should be a palindrome regardless. So that's how we're able to account for like an even amount and make sure that when it's flipped, everything's the same.
Okay, got it. Yep. Yeah, that makes a lot of sense. So you're basically what you're doing is you're reversing the array. You're creating the substring from and slicing it from the jth index to the j plus one index. And then
I
you're
plus I.
reversing the string and checking
Yeah,
that
right.
that
Against our actual string.
okay, good. What's what's the complexity here? What's the runtime? And then what's the space complexity that you're using for this solution?
I think the time complexity, well, the space complexity should just be O of one since we're only using strings. But as far as the time complexity, I think this is O of n squared or log n. I think it's over n squared because we're slicing each time that we go through. So every time we're in the J loop, we keep on slicing. And yeah, it's O of n squared, I'm pretty sure.
And then for your you're right. It is O of n squared because you are iterating through the loop through the characters of the string uh, more than one time. So you're slicing and then checking for reverse substring. So there's two
Right.
operations for and checking against every single character inside of the string. So yeah,
Yeah.
that and scored.
So
Uh, so your space complexity, it looks like you're slicing quite a bit. So
so
can you talk about the
maybe
method?
so I guess the main issue is our substring. So I mean the substring is gonna be as long as our n here from the two loops, right? So this probably is O of n sub space complexity is all then. Since we're only storing one substring at a time and it'll be of length n.
Okay.
I
So
mean,
it's
go
always
ahead.
so whenever you're slicing in Python, it's
Mhm.
basically creating a new copy of the string.
Right.
It's always going to be the O of I, which is the length of the string. I is
Hmm.
just so so yeah, so at most it can take O of n, just like you're saying,
Hmm.
because it's just basically the length of how many characters are in the string. Um, and I'm trying to think if there's a more efficient way to do this. There probably is. Um,
Definitely, definitely.
where you don't have to, well, you have to slice. I don't think.
I think the better solution I think was dynamic programming.
Okay, you can actually do this in a more efficient way, where you're
Right.
not slicing as much. And the way that you do that is that you actually create the expand around
Right.
um, algorithm, which basically says that it's just a while loop that starts with the left.
Oh, okay.
Makes sure that the right and the left pointers are bounded, right? So if you put the left pointer on the first character and then the right on the last character, you pretty much want the loop to bound it and then also say that if they're equal, then you keep expanding. So it's like
Right.
that middle expansion thing, right? But
Hmm.
the moment that that while loop doesn't execute, it means that you've got like your first palindromic substring, right? And then you can just return that, and that'll just be one part of this. So when you do return it, you'll have to slice that array, right? You'll do one slice. You'll just
Right.
basically you're only gonna slice until like you call that expand around method, right? So what does that do? That basically I guess in the hindsight of things, it does eliminate some slicing, but I think it's still gonna be a order
I
O of
mean,
n operation.
could you still use dynamic programming for this because we need to basically use our past iterations of the substring to find a bigger substring, right? I mean,
You
is that a
could, but
possible solution?
But you could, but let's think about it. How would you arrange the dynamic program? You don't have to code the solution, but just think about like in dynamic programming, what structures would you use to be able to dynamically program something to code a solution? You don't have to code it. Just you can just say something out loud.
We would be using an array.
Okay, we're going to use an array. Then how would you use dynamic programming within the array to find the substrings? So is it going to be an iterative loop, just like you're using here?
Most likely, yeah.
Okay. So if that's the case, then you're probably going to be still bounded by order of n squared, right? Because are you going to use
Yeah,
two?
definitely. Yeah, I agree.
Okay. So that would, yeah. So I think your solution here is probably the most optimal here. But let me check actually, because I don't know. I want to check the solutions and what other people did. Maybe I can so here we go. So yeah, there is definitely a dynamic programming one here. Um okay, so here's one that I was actually thinking of here. Okay. So I'm gonna put this one down here. This is just gonna
Sure.
be the okay. So this is basically like a different way to do it here, right?
Mhm.
But it's exactly what I was mentioning, right? So you're gonna have an expand around, and basically what this is just a helper method that you're gonna keep calling.
Yeah.
But the real idea here is like, okay, all you want to do is just keep expanding while these two are equal, right? Because if you know that those two are equal, then you're gonna keep having these palindromes. So
Hmm.
you're gonna shift left, if I'm looking at that correctly, and
Yeah.
then right to the right. And then you're
But
gonna want to, what's that?
isn't this still just as bad in terms of time complexity? I think this is order n squared as well.
This is order of yeah. Because you have this loop,
And
the
then you
and
make the call and it does another loop.
keep making the call. Yeah, exactly. But notice here, this is kind of the cool thing here is that he's accounting for odd and even here
Hmm.
individually.
Oh,
So
right.
yeah, because so how does
And
he
then it
do that?
takes the max at the
Yeah,
end of the
exactly.
call.
Whatever is
Okay.
bigger.
Yeah, that makes
So it's
sense.
kind of it's kind of wasteful in my opinion because you're having to do this two times, even though like maybe one of these won't even be factored into the final thing.
Mhm.
So that is a little bit wasteful. That's some extra operations there, but it's completely fine. And then basically at the end, what he does is he just basically figures out the max leg. And then the solution is a sliced version of the computation that he does here.
Hmm.
So, but if you look at his solution, look at yours. Yours is much cleaner. How many lines of code is this?
Probably like 15. No, probably like 20.
Actually, this is a great solution that you came up with. Um, much cleaner. In the coding world, you want to do as less and have about the same impact
Right.
as other code. So, but I'm going to quickly check to make sure this is right. Um, make sure. So it's ABA. So yeah, that's correct. I'm going to throw this in leak code real quick, if you don't
Sure.
mind. Um,
I'll try myself.
yeah, give it a run. It's always good to because leak code does test with like all the test cases.
Right.
Python Intern.
Accepted,
Yeah,
just not the quickest though. But
this is sweet because look, you solved this in 30 minutes. This is a medium level problem. You don't have to like you know how it says like you know how it says like it only beats 18% of the
yeah,
you don't really have to pay attention to that. As long as you have like a running solution, you're good. Um yeah, because some of this there's a bunch of different factors of why. And the other thing is that if you do clean up a lot of the slicing that you're doing,
hmm,
you could improve that by a little bit, but it doesn't really matter, to be honest with you, at the end of
gotcha.
the day. Good job.
Thanks. Do you have another question that you could give me or anything like that?
You
Uh,
want to go for another question, or you want to talk about your project?
I mean, do you have time for another question?
Yeah, yeah, we do. But the only thing is that I might not have time to go through another or through your project, so
What time do you have till?
I have to jet out of here a little bit after 10. Yeah.
What time is Okay. Okay, yeah, so it's probably just stop this then.